So I know that's a pretty bold claim saying this is the best video out there for a standard electrical outlet and giving all the basic information you need to know, but you be the judge. Watch the video, let me know in the comments. There's a few different sections that we're going to go through. Overall, we're going to start here with basic tools. What do you need to do the job and what should you be investing in? Then we'll touch a little bit on wiring. What is the common wiring you'll find in residential homes, 1970s or so and newer? We'll touch on the different types of outlets. If you've ever walked down the electrical aisle at Home Depot or Lowe's, you know there are a ton of options. So we'll try to make some sense out of that. And then, of course, we will go ahead and wire an outlet, showing you best practices and some options and features you might not know about on a standard outlet. So let's jump into it and talk about tools. So here's your range of testers, starting off with the basic outlet tester. I think this is a must. If you're going to be doing any electrical projects around your house, you definitely should have an outlet tester. You're going to plug it into a standard duplex outlet, and it's going to show you the state of that outlet by a combination of lighting up these three LEDs. 2 orange would be a correctly wired, powered state. If you see no LEDs, it is off, so that circuit is off. And then a number of combinations of issues that will help you in your troubleshooting to correct said issue. Also, it's nice to get the ones with this little test button. That is to test your GFCI outlets in your kitchens, your bathrooms, your garage. These are very cheap and a must-have. Next up on the must-have is a non-contact voltage tester. I prefer this 3P from Klein Tools. Like the outlet tester, a non-contact voltage tester is very cheap. So you can usually get these in a pack, outlet tester and the NCVT, which is the abbreviation. No matter which brand you go with, I would just look for when you turn it on that you see a green LED. What this is going to do is make sure you have battery power in your tester. Some of them without the green LED can be confusing. You might think you do not have power at a wire you're testing, whether it's a light switch or outlet. You actually just don't have battery power in your tester, so that can be a dangerous situation. Also, I think you should be getting one with a light. When you're turning off circuits, you could be working in the dark, and it's nice to have some light readily available. So I think these two you must have if you're doing electrical work around the house, and then a multimeter is kind of your next level up. Any electrician is going to have a multimeter, and really trust this tool, especially over the non-contact voltage tester. So depending on your level, you might want to also invest in a multimeter, and I think Klein Tools makes a good middle of the road version. Next up, you're going to need a good screwdriver. So you're going to be doing a lot of work with terminals, whether you're doing light switches or updating all your outlets in your house. Everybody's going to usually default to a Phillips head, but the Phillips head, when you really torque something down, it's going to slip or cam out, and that could start to strip that terminal. So there are better options. One option would be a number 1 square or a number 1 Robertson screwdriver, and that's going to fit right there in the middle, and it gives you a really nice snug fit that's not going to jump out of the terminal, and also you can really torque it down. But then really at the higher end is this hybrid combo bit. This is made by Milwaukee. It's called an ECX number 1, and it takes advantage of basically the entire screw terminal. So it kind of gives you the best of both worlds. You can really tighten it down with one hand, and it's not going to jump off that screw terminal. So those are your options depending on what you're looking for. And then wire strippers. All these wire strippers are actually a combo. So they have the wire strippers themselves. They have the standard features, which we'll go over a little bit later on. But then they have the wider jaw on the end, which can help you pre-twist wires and just give you a little more leverage. I would say this is good, better, best. So Klein Tools makes one, which is a good hybrid. This is the one I've been using for a bit. It's the Milwaukee wire stripper, and again, it's the combo with the larger jaws. And then I just got these guys, which is again a hybrid. It's got the wider jaws, has a few additional features of stripping Romex made by Knipex, and then it has the one-handed lock that you can lock or unlock the jaws. These are supposed to be very nice, high build quality, and last a long time. Now you can get very cheap and inexpensive wire strippers, but if you're going to get one, I would just go with the hybrid because it kind of has two tools in one, which I think is great for the DIYer. And also, if you have 20-year-old wire strippers, get new wire strippers. You're most likely going to be damaging the wire when you're stripping it because they're so dull and beat up. So it is something you want to invest in, especially if you're doing multiple electrical projects around the house. One additional bonus tool is a good utility knife. I like the one-handed operation of the fastback, and it also can hold 5 new blades. This is especially important when you're dealing with wiring called Romex, which we're talking about next, because you need to cut back the sheathing so you can open up the conductors. But you can look below this video in the description. You'll see a link to the Everyday Home Repairs Amazon store, and then that has an electrical section which will give you links to all those different tools. Next up, let's talk about wiring. It doesn't need to be confusing, but it can be a little bit confusing. The most common type of wiring in residential homes after about 1970 to present day is what usually is called Romex. One thing to note, Romex is the brand, but it's just so popular, it has actually become synonymous with NM-B cable. That is non-metallic sheathed cable, which is the go-to type of wiring in residential construction. But let's touch on what does 14.2 mean and what do you need to get? So I have 4 examples here of common Romex. This is the most common Romex that you're going to see within standard residential, especially when we deal with outlets and light switches. So we have white, which is 14 gauge, and then we have yellow sheath, which is 12 gauge. 14 gauge wire is commonly used on 15 amp circuits, and then 12 gauge wire is commonly used on 20 amp circuits. Then the 14.2, like we saw the bag, is actually here. So the 14.2 actually indicates 2 conductors, the black hot conductor and the white neutral conductor. The bare ground wire here is not included. Also should be noted, these are all solid core wires. If you start dealing with light fixtures or some smart light switches and other devices, you'll see that that will be actually stranded wire. So Romex is going to be solid core. So 14.2 would be 14 gauge 2 conductor. 14.3 would be 14 gauge 3 conductor. You're going to have 2 different hots. You're going to have a black and a red. That is the most common. And it also should be noted, just because I'm telling you that black is hot, red is hot, and white is neutral, remember your wiring was done by somebody before you. So assuming they connected everything correctly and used the correct wire colors, that is not a safe assumption. You definitely need to bring caution whenever dealing with your home for the first time as you kind of unfold what is done before you've owned the home. And then 12 follows the same logic, right? Thicker gauge, solid core, copper, but this would be 12.2 and this would be 12.3. Most commonly in homes, you're going to use 14 or 12.3 for like 3-way light switches where you need some traveler wires, which you would use the reds here, to connect up different light switches so they can work with respect to each other. The 12.2 and 14.2, 14.2 might be going to a bunch of different light fixtures. Maybe you have a bunch of recessed lights, and then you have 14.2 daisy chaining between all those. And then 12.2, super common, going to all of your different outlets in your home. And again, that's going to be able to carry 20 amps. So this should be on your 20 amp circuit. So that does it for wiring, especially dealing with modern homes. So if you have a home that's older than 1970s, you can have everything going back to knob and tube or some version of early Romex. And you can look down in the description. I'll have the playlist to all our electrical videos. Some of those deal with knob and tube. So I'll give you a little direction on how to handle a home with older wiring. All right, so let's touch on types of receptacles. Starting over at the lower end in terms of cost, you would have a very cheap, usually 50 to 75 cents for a residential grade 15 amp duplex outlet. Should be noted, for many years now, you're supposed to be installing TR, or tamper resistant outlets. And what that does, it makes sure these small plastic gates, they do not open up unless two different prongs are being pushed into the plug. So if a small child was pressing something within this small slot, which is the hot side of your outlet, that would not open up. You'd have to introduce two, like a prong for a plug, in to open those gates up and then allow it to connect to the outlet. So it's supposed to be a safety feature. Now, these are not tamper resistant, but these would be the next step up, and you can get these same versions in TR, in tamper resistant. These are commercial grade. They're the first level of spec grade from Eaton. I prefer these. If you're going to be doing your own DIY, these are going to be more like $2 or $2.50, and it's worth the money. Their construction is superior to the residential grade. So look for a spec grade or commercial grade of outlet. I like Eaton, I like Leviton, I like Legrand. I think they all make good outlets. This is a 15 amp, and then if you see on the neutral side, you see a horizontal slot, or this horizontal T. That's because this is a 20 amp outlet. So just be clear with if you're supposed to be using 15 amp or 20 amp. 20 amp is probably going to be more common in most homes. So most outlets, you actually have options when it comes to wiring. So this is a residential grade, and there's two options on this one. You could either wire using the side terminals, and that's going to be called side wiring, or you can use a feature called speed wiring. Many people call it backstabbing. Backstabbing only works, this would be your neutral side, for 14 gauge wire. So you just press that in there. What I do recommend is two types, either side wiring, I'll show you how to do that, or if you went with the commercial grade will actually have a feature on the back here. You'll see that plate inside where you can tighten that down, and you do not have to make a hook around the screw terminal. That is called back wiring. That should not be mistaken with speed wiring. What I just showed you on speed wiring and back wiring are two very different things. If I had to pick one for DIYers, I would pick the commercial grade and use back wiring. But let's show an example of both. First, let's get our bearings about us. Gold terminals here, gold screw terminals indicate your hot side. Those will be on the same side as the smaller slot here on both of your receptacles. Then you'll have your silver side, which is your neutral side, and then always a ground screw for your bare copper ground. Now on the back, you will have a strip gauge, which you can reference your wire in, and that will show you to here how much you need to strip off. One thing to point off, you can see strip gauge, is that is actually only a strip gauge for speed wiring. The same on the commercial grade. The strip gauge here that we would use, right, to see how much insulation do we need to remove, that is only for back wiring. That is not necessarily how much you should be stripping if you're going to be doing side wiring. So just a note. So for stripping wire with your wire strippers, you're going to reference your gauge here. You have a solid side and a stranded side. Here I have 14 gauge, and I need to strip that to 14 because it's 14 gauge wire. Now I'm stripping about 3/4 of an inch. When you strip, you want to have new sharp strippers and pull straight out with those strippers. What you don't want to do, let's do it again, you do not want to go in and then you have dull strippers and you have to go back and forth and work it to get that insulation off. Because what that ends up doing, it ends up nicking your wires. You can see those small nicks in the wires, damage. Now, depending on how much you damage, that could be a hot spot. And if you start to bend your copper, so when you're installing it, you're doing your J-hook, you're bending it, that can be a quick failure point. You can snap off your wire. So just be careful not to damage your solid core copper as you're stripping off the insulation. And then pretty much all wire strippers are going to have some part where you can use it to do a nice J hook for some side wiring. So that's going to set you up well. Then I would take my hook here, called a J hook or shepherd's hook, and I put it in the clockwise direction around the screw terminals. I'd make sure the wire is secured using a screwdriver. Here I'm using the ECX number 1. I would tighten that down, and because I put it in the clockwise direction, it's going to pull the wire in opposed to push the wire out as you tighten up. Now what you like to see is you do not like to see insulation past the end of the housing, because that could equal a fault later on if you have exposed copper, especially when you're on your hot side. Then if a ground or something comes in contact, or the housing from a metal electrical box comes in contact, you can create an issue. Now let me show you what would happen if I actually just used the wire stripper gauge here and only stripped off that much wire. So that's going to be a little closer to 1/2 inch. All right, so I'll strip that off. Now that would work well if I was using speed wiring or even back wiring on the commercial grade, but let me show you the issue if you're using it for side wire. And you might already see where the issue comes in. Again, a clockwise direction, put that around the screw terminal, and then we'll go ahead and tighten that down. And this one isn't too bad, but what you start to see is you're going to start to pinch insulation underneath your screw terminal. It's not a showstopper. This terminal will work and probably work for a long time, but now you have a possibility maybe it to work loose over time after that insulation maybe heats up over time. It's just better, like on our neutral side, to have all copper underneath that. It's just going to be a better overall installation. So it also should be noted that if you have unused terminals, before you put the outlet back in the box, go ahead and tighten down those screw terminals. It's just best practice, and you can see it thins up the profile of your outlet. So go ahead and tighten down all those unused terminals, and that's just gonna, again, be best practice and hopefully avoid issues in the future. And then for your ground, probably goes without saying, but it's just going to be something very similar. And then just to show the completed outlet, we'll go ahead and do a shepherd hook on our ground, again in the clockwise direction. And then just to show you the difference, let's do one wire on the neutral side on these commercial grades and using the back wire, which again, I do prefer. This time we will use that strip gauge. That strip gauge is going to be a little bit closer to a 1/2 inch there. So here's actually 2 inches, 1 inch, 1/2 inch in the middle. It's going to be about right at the 1/2 inch line on how much insulation you're going to strip. All right, so now we have the commercial grade. We have our silver screws, which is the neutral side. The plate, you can see the plate is pushed back. So I'd insert in my wire, and then you're going to tighten down the terminal, which is pulling that plate on the back side against the wire and then pinching the wire in there. I think this is easier. It's a little less learning curve. J-hook, shepherd hooks takes a little getting used to, not super complex, and then I just like the overall fit and finish. It's easier to get 0 exposed copper hanging past the housing. So I do prefer back wiring. I use back wiring because I use these spec grade, usually Legrand receptacles, but I've also used Eaton and Leviton in the past. So other things to note which might help you out. These tabs here are usually made to keep the overall depth correct because these will hit your drywall, and then that will match up when you put a face plate over your drywall. Sometimes, depending on your home's construction, you might need to remove these, and you can see there are pre-cut lines. You can remove these tabs here, you can remove the tab across there, so that can be easily removed if you need it to line things up. Also, sometimes these screws, you might lose them, they might get damaged, they're not correct length, but you don't have to worry. These are not fancy screws that you can't get anywhere. They're actually just commonly available machine screws, number 6-32. And if you need longer ones or you just need more, this one would be a little bit longer one. And then overall, I can cut this to size. So most wire strippers are going to actually have these small bolt cutters on here, one for the 632s, one for the 832s. So what you do is you just put the bolt within your strippers, and then it takes a little bit more force, but you can go ahead and cut that off clean. It does bugger up the ends a little bit. So you can do that for 632s, or you can do that for 832, which is the type of bolt you need to usually mount like a light fixture to the electrical box in your ceiling. Also, you might need to space. So you can get small spacers that would go on the back side here and help to space your outlet out a little further from your box. And then one more thing to touch on, you might see a receptacle that you're swapping out that has a black and red two hots coming in of different color. And what you also see is that this tab right here between the screw terminals is removed. So what does that mean? That means you have a switched outlet. Switch outlets are very common in my area in older construction homes, 1960s, 1970s, and even in some of the higher end homes. Maybe you have a plug by your bed and you want to put a lamp in, so they put a switched outlet there. Just be careful. If you're removing a switched outlet and you're wiring it back up the same way, you need to remove this tab on the hot side to make sure you have the on-off capability of the light switch. If you don't, you're just going to have an always powered duplex receptacle and a light switch on the wall that doesn't do anything. So that should give you a good baseline, and I do recommend if you're diving into electrical and you want to just continue to build out your knowledge base and be safe about it, Black & Decker makes an awesome book. It has all the different scenarios. This is an older one. This is the 4th edition. And I would hold off, I think February 2022, the 8th edition's coming out. So that's going to have all your updated NEC, so all the updated codes, and would probably be worth the money. Again, you'll see that on our storefront, link in the description for the Amazon store for everyday home repairs. Now, if you're changing out an outlet and there is more than one set of wires coming in, that is super common, but can be a little bit overwhelming. Check out this video right here and I'll walk you through what to do in the process to get that wired back up and using a technique called pigtailing. So thanks for joining us on this video, and we'll catch you on that next one. Take care.